Okay, let us start our discussion on finding the asymptotes. Before going to this, how to find out an asymptote, we should know some basic thing. What is the basic thing? The behavior of the roots as the coefficients approach zero. You should know these things. Suppose, for example, we have a quadratic polynomial x square minus 6x plus c uh, plus 5 is equal to 0. You know that if you solve it, the roots will going to become 1 and 5. But the coefficient of highest degree term, that is coefficient of highest degree term, is what here? For example, if you take this one is, let me take this ax square minus 6x plus 5. Initially, if a is equal to 1, you can get the roots like this. Okay. Then, if you 1, the coefficient of 1, this x square is, if you a is, if you decrease, if it decrease these things, what happens? The root, see, check it. If it is 0.1, this is the equation becomes, and the roots becomes like this. Here the roots becomes, one of the root become increasing here. It means that the one of the root becomes in going to become infinite. See here, decreasing the leading coefficient means one root settles near and one the root gets to infinity. What about if the both the roots going to decrease? Sorry, not both the roots. I can say that the both the coefficient. I can say the coefficient of first degree highest degree term and second highest degree term will going to decrease. Both a and b. What about the roots here? See, if initially if we take the coefficient zero point 0.1 and b is equal to -2, and the equation becomes like this, because in the place of a if you substitute 1, and in this place of b if you substitute -2, this equation becomes like this. Then is, if you solve it, the root going to become here like this, 2.93, and approximately this is not which is approximate symbol, which is approximately goes like this, 17.07 like this. Now if you decrease both the coefficients here a and b, see what happens, the both the roots are going to become increasing. Means it means that the decrease the both first and second coefficient, the both roots going to become going to infinite. See, this is the case. If it is cubic polynomial, then if you I can say that three coefficient, if you decrease in the similar variation, if you decrease the three coefficient becomes, I can say that three roots are going to become infinite. In the sense, if you decrease only one root and the one root going to become infinite means disappear, you can say it like that. Only you can get one. This is called infinite root for this, you can say that. Means they, why it is infinite? That because it is very going to become very large as we I can say that that is called x. See here, this is how, this is the basic idea for with this concept. Let us move on to this one. Now with this concept, suppose we know that an asymptote, how to find out asymptote for a given curve. Okay, we have to, let us start our discussion. Suppose there is a curve is given, f of xy comma 0 is a curve, and I want to find out an asymptote for this curve. What we can do, we are going to study here. Suppose we know that asymptote is that a curve approaches but never touches, is a straight line to that a curve approaches or but never touches, meeting at infinity, that is called asymptote. To find it for f of xy, use the condition that equation must have infinite roots at intersection. Means whatever this y is equal to mx plus c, we're going to touch this curve of f of xy at infinite. Means as x tends to infinity, see here, x tends to infinity, if I say y is equal to mx plus c is the base asymptote to this curve, then if x tends to infinity, y value should get here y is equal to mx plus. It otherwise I can say that at infinity, this whatever this point mx plus c, x comma mx plus c will going to satisfy this curve equation. The point on a line that is x comma mx plus c will going to satisfy this curve equation at infinity. That is the thing, because at infinity will going to touches it. See here what I in the previous classes we already told you, if suppose y is equal to c is an asymptote, the x tends to value x tends to infinity in the curve, the y tends to some c, then y is equal to c is an asymptote here. In a similar fashion, here in this curve, as x tends to infinity, is y value, if you get like this mx plus c, then you can say that the asymptote for this curve is y is equal to mx. The same condition here. Then what happens? See, if I assume that y is equal to mx plus c is an asymptote for this curve, then what happens? Is an asymptotes at the infinity, this f of x comma y is equal to, if you replace y is equal to mx plus c, whatever the you get polynomial, this will going to satisfy the this equation of the curve at the infinity. But condition for meeting the infinity, we already studied, the coefficient of highest degree term must equal to 0 here. And in this case, if you coefficient of highest power in the f of x, it contains m here. And if you equate to 0, then what happens? If you get solve it, you can get slope here. And if you again make the second highest power coefficient is 0, because we already know that y is equal to, we are going to assume that y is equal to mx plus c is an asymptote for this one, and this, whenever if you substitute y is equal to mx plus c in this equation, this will going to equal to 0 whenever I can say that x is tending to infinity. This will going to satisfy only when x tends to infinity, and for this curve. But to x tends to infinity, what happens? What is the requirement? That is the requirement of the coefficient of highest power in the this f of x y comma becomes, whenever if substitute y is equal to y plus mx plus c, still it is not satisfied. Only condition is required. Still it is extends to infinity. Not to make extends to infinity, the coefficient of highest power in that, I can say that tends to 0. Can say that make it 0, then only this condition will be satisfied. Under such condition, if you find out m and c, then, and you can also the second highest power coefficient is set to 0, and under such condition, if you find out m and c, what happens? That under such m and c, two things are true. One is, actually, if I initially assume that y is equal to mx plus c is an asymptote, under what conditions we are going to check it? Under these conditions, because one thing is an asymptote means this will going to satisfy the equation. Under what condition? Under two things. One is at x tends to infinity, this will going to satisfy equal to 0. By making those conditions satisfy, and if you find out the unknown constant, if these are the values of m and c, this condition is, you are going to make conditions means I can say that we're going to initially assume that y is equal to mx plus c is an asymptote. Then if I say immediately if it is an asymptote, two things happen. This one at the infinity is going to satisfy the condition. This means in the place of y you can get mx plus c. Whatever the line on the mx plus c is going to satisfy this condition. The equation, the curve equation becomes g of x is equal to 0. And again here, and since it is an asymptote, as x tends to infinity, this equal to satisfied. Under such condition, under what condition? If this is the condition is satisfied, and what is the value of m and c we are going to find out. Now, if you make a condition for an asymptote to be satisfied, then this is the value of m and c. Then the m and c should be like this. Then only you can say that. Then we can say that y is equal to mx plus c is an asymptote. This is how we can find out an asymptote. What we are going to do here, simply with the given curve f of x y is equal to 0, since we are going to assume some y is equal to with mx plus c where m and c are unknowns, and we are initially going to assume this is an asymptote. If this is an asymptote, this will line going to at infinity, it will going to satisfy this equation curve. Therefore, we are going to replace y with mx plus c. But that what? But what? The x tends to infinity. Now to make x tends to infinity, we are going to the coefficient of highest power in the g of x going to become tends to 0. In such cases, if we find out m and c, these are the m and c, and if this is the value of m and c, these three conditions are satisfied. Then I can say that unknown we are going to find out m and c. For such value of m and c, what happens? This is the condition you are going to initially set for the whatever the requirement for an asymptote, we are going to set it under such condition. If you find out m and c, then you can say that this should be y is equal to mx plus c. In order to make it an asymptote, these are the value of m and c. Then finally you can find out the by putting value of m and c in the equation, you can get you can say that you can find out. This is how you can find it. Thank you. Asymptote.